In this video, we're going to look and see whether a table is linear or nonlinear. The learning target here would be I can determine whether inputs and outputs are linear or nonlinear. Inputs are your x value and outputs are your y value. So I'm just going to write that here. Input and output. Okay. So on this table, we're looking to see whether it's linear versus nonlinear. Something that defines something as linear means that it has a constant rate. So I might write that as a note somewhere and say linear. The definition of linear has a constant rate of change. And remember, rate of change represented mathematically is the change in the y over the change in the x. Okay, so we're going to dive into that and see which one of these tables is linear and which one of these is nonlinear. Looking at the first one, in order to find our change of y over change of x, the first thing I'm going to do is set that up over here and just write change of y over change of x. And I'm going to start to check those. My change in y right here, 5 plus something gives me 8. I can figure that out by doing 8 minus the 5 to get plus 3. Change in the y here is 3. And the change in the x is 1. Okay. Using some colors just to make sense of what we're doing here, I'm going to say that our y is yellow and that our change in our y is everything we're going to find here, change in our y. Change in our y is 3. How are we getting that? We got that 3 by doing 8 minus 5 to equal 3. 8 was one of the next output, and I took away my other output to get my change. Okay, the difference there between those two values is 3. Change in the x, I'll show as blue, and that's change in the x. Change in the x is represented by finding the difference between the two x inputs, the two x coordinates there. Okay? So when the y is changing by 3, the x is changing by 1. When the y is changing by that 3, the x is changing by 1. Okay, I've already have that simplified down to a unit rate. It's over 1, so I'm going to leave it the way it is, and I'm going to check my next pair. So looking here, in order to get from 8 to 14, what's my difference? 14 minus 8 gives me 6. So that's a change of 6. I'm going to say my new change in my y over my change in my x is 6 over, and that's going up by 2. 6 over 2. When I simplify that, 6 divided by 2, because remember, this is a fraction, and a fraction is a division problem. So when I simplify that division, 6 divided by 2 is simplified down to 3 over 1. And again, using our colors here, there's our change in our y. And the change in the x is right there. Okay? So far, I'm seeing that this rate is equivalent to this rate. That means 6 over 2 is the same as 3 over 1. And so far, this table has a linear rate of change because they can both be simplified down to 3 over 1. Checking the next pair. So you have to continue through all the entire table to see if it's linear. I want to know from 14 to 23. Well, that's 23 minus 14, and I get 9. And then the change here is 3. And so I'm going to set up another change of y over change of x, and that change of y is 9 over your change of x is 3. Change in the y is 9, and that's where the 9 is, over that change in the x is 3. There's that 3. If I do that division problem, 9 divided by 3, and that equals 3 over 1. And I see that that 3 over 1 is identical to the other unit rates. And because all 3 of those rates are identical, we're going to say that this table is linear. Oops, It's linear. It's linear because it has a constant rate of change. It has the same change of y over change of x. When I simplify it down, they can all be simplified to the same value. We're going to check the next one. This table, the x is the input, y is the output. Okay. And we're going to set this up by starting with change of y over change of x. And I'm just going to draw a line here so I know that I'm now on my new problem. Change of y here is 5 to 8. We saw on the other one that that's plus 3. So I'm going to write 3 over 1. And as I do this, there's my 3. They're all my change of y's. Here's my 1. It's my change of x's. I can't simplify that because it's already in simplest terms, so I'm going to circle it and go to my next one. 8 to 11 is 3. So this time my change of y over my change of x is 3, right? Here's that 3. There's that 3. There's that change of y for 3. And getting from 1 to 3 is going to be a change of x of 2. 2. Change of x is 2, so I wrote that 2. And as I simplify this, 3 divided by 2, I end up with 1.5 for every 1. And my change of y is saying that I'm increasing by 1.5 every time my x is increasing by 1. And I see right here that it's nonlinear. It's nonlinear because this unit rate, this simplified version, is different than this simplified version, and therefore that makes it nonlinear. I only have to find it nonlinear one time for it to be nonlinear, whereas in this one I had to continue out the entire thing to make sure they were all linear. But in order for something to be nonlinear, I just have to meet that criteria one time. I can continue this if I wanted, and I would say this is again plus 3, and this is plus 3, and I would see that 3 over 3 is also going to be nonlinear because it's going to simplify down to 1. But at that point, we've already distinguished that it's nonlinear. So it is nonlinear, that one is linear.